In this video, we'll look at question 29 from the 2016 paper. In this question, we'll look at a rod isolated from its surroundings, which has a temperature T1 to one side and T2 at the other side. And due to this temperature difference, there will be heat flowing through it from the hotter end to the colder end. And our task is to say which of these 8 proposed changes in the geometry of the rod or in the temperatures will not affect the rate at which the heat flows through the bar. So let's first have a look at how the area affects the rate of conduction. So let's imagine, say, we have a fridge and a stove connected with this bar, and now we decide to add another bar just like that. So how will the rate at which heat is flowing from the stove to the fridge change due to this alteration? Well, it will double because the heat will flow through the first bar, but at the same time also through the second bar with the same intensity, and hence we will double the rate of heat transfer. And having two same bars is the same as doubling the cross-sectional area, and so we have found that flow of heat will be proportional to the cross-sectional area. The next dependence we'll investigate is almost trivial. If one bar connects a region of 0 degrees to 50 degrees and the other one from 0 to 100, the heat flow on the bottom one will be twice as much as on the top bar. And so we can say that the flow of heat is also dependent on the temperature difference across the bar. It's not the absolute temperatures that matter, but their difference. So the flow will be the same whether we have 0 to 50 or 1000 to 1050. Finally, we'll consider 2 bars of different lengths. We can see that when the top bar is twice the length of the bottom rod, the temperature at the same point away from 0 will be half that of the bottom rod. So by the same logic as previously, the heat flow through this region and hence through the whole rod will be half that of the bottom. And so we have an inverse proportionality to the length of the rod. And now that we have investigated all these dependencies and we have our little formula, we can see that changing only the area or only the length will always change the rate of flow of the heat, or the rate of conduction. So if we only double or only half the area or only double and only half the length, that will always half or double the rate of conduction. So the first 4 options all have to be wrong. And of the 4 changes in temperature, the only one which doesn't change the difference, delta T, so it either decreases or increases both temperatures T1 and T2 by the same amount, is H, which increases both by 10 degrees and makes no geometric changes to the rod itself. So the correct answer is H.